Hi everybody, I hope you're doing well. This is our lesson for today, Thursday the 13th of August, and I know you have physics period 3, so I just thought I'll make a little video before we have our Zoom meeting at noon today. Today's lesson and also tomorrow's lesson is to do with Ohm's Law, and I know you've done this in year 11. However, I'll just refresh your mind about this. So Ohm's law has to do with the relationship between current and voltage. So it says that provided the resistance is constant, that means at constant temperature, the current in a wire is directly proportional to the potential difference of the voltage. So what does that mean? I'm just going to use an analogy of, let's say you've got two tanks of water. So let's say there's a tank of water here, and then there's another tank of water at a slightly higher level. So, oops, blue pen doesn't seem to open. Okay, so there's some water here, and there's a lot of water there. Okay, so these are two tanks at two different heights, and if they are connected some way or the other, so if it's possible to connect these two tanks together, what's going to happen is that the water is going to flow through from one to the other, so that the level of water in this rises as the level of water in the other one decreases till they're both at the same level. This is kind of like what happens in an electric circuit. So if something's at a higher potential, there needs to be what we call a potential difference in order for a current to flow. So it's this potential difference that drives the current. So you need that potential difference, and your potential difference, or it's the amount of energy carried by each charge, your voltage, that's what drives the current. So in the Ohm's law experiment, what we do is to try and find the relationship between voltage and current. So what we did last year is you had a power pack which was connected to a rheostat, and a rheostat is there just to change the value of the current, and then you've had an ammeter to measure the current through the circuit. And then you had a coil of wire, and we put this coil of wire into water, and the reason that we did this was to keep the temperature constant, because if the temperature increases due to the current passing through the wire, what's going to happen is that the resistance of this wire is going to change, and we wanted to keep that constant. And then across the wire, we had a voltmeter to measure what's the voltage across this wire for different currents when we changed the value of the resistance. And then we got values, we got a whole set of values, data for voltage and current, and then we plotted a graph of voltage against current. Now voltage is measured in volts, and current, the current is represented by the letter I, and you might wonder why. It actually stands for the intensity of current. That's why they call it I. And that's measured in amps. And you get a graph, which is a straight line. And the straight line graph tells us that as current increases, voltage increases. So we say that the voltage is directly proportional to current. Whenever you have a proportional relationship, you can have what's called the constant of proportionality, and this constant of proportionality is resistance. So, and how do we find the resistance? The resistance is found by the gradient of this graph, and the gradient of this graph is V over I, which gives you resistance. Now, voltage is measured in volts, current is measured in amps or A, and resistance is measured in ohms. Now, any conductor that obeys Ohm's law, you will end up with a straight line graph. However, just for further information, there are some many things that don't really obey Ohm's law. For example, in year 11, you may have done this where you replaced this coil of wire in water, you replaced it with a lamp. You can't dip the lamp into water. And if you measured the voltage across the lamp for different currents and you plotted a graph, your graph would not have given you a straight line. In fact, what would happen is you got your voltage, you got your current, and current is in amps, voltage is in volts. You have a graph that goes like this. If you look at it, the slope of the graph is changing. So that tells you that the resistance is changing. So it implies that as the current increases, the resistance increases. Okay, so that's what this implies. Okay, and conductors that don't obey Ohm's law are called non-ohmic conductors. All right, so this is just a background for you. Now, our task for today is to solve a few questions on Ohm's law that is in your booklet, and it is over here on this page. And we're going to look at questions 1 to 3 today, and then for tomorrow's lesson, we'll do questions 4, 5, and 6. So I'm using 2 lessons to solve these problems. So I'm just going to do question 1 with you, and then I'll get you to work through the others on your own. You should be able to, and I'll try and work these out and put the answers up on Google Classroom. Okay, so let me just draw the circuit. So this is question 1. It's on page 19 in your books. So you got a source, you got something in series with the source, 3 amps. Okay, let me just get the values. So I'm going to use, oops, it's fallen down. I'm going to write the resistances in red. So this is a 4 ohm resistor, 3 ohm resistor, and a 6 ohm resistor. And we also know the supply voltage is 18 volts. Okay, first thing, in the circuit shown, calculate the total resistance of the circuit. And the way we do that is first find the resistance in parallel. So resistance in parallel is you do 1 over RT equals 1 over 3 plus 1 over 6. Or this is equal to 3 to the power of -1 plus 6 to the power of -1. So resistance in parallel, it's my calculator, is, okay, you go open brackets, 3 exponent -1 plus 6 exponent -1, close brackets, exponent -1, equal to, and I get 2. So that's what I get on my calculator. So this works out to 2 ohms. Total resistance is, you got to add, that works out to 2 plus the 4. So your total resistance is 6 ohms. Okay, so we've got A answered. And then B is calculate the current drawn from the battery. So the current drawn from the battery depends on your battery voltage and the total resistance. So current drawn from the battery is V over R. Your battery voltage is 18 volts. Your total resistance is 6 ohms, and 18 divided by 6 is 3 amps. So that's the current drawn from the battery. Now use the current through the 4 ohm resistor to calculate the voltage across this. So all the current goes through that one. So the answer to that is voltage across the 4 ohm resistor. So I've just put a 4 there so you know which one you're talking about. So voltage is current times resistance. Your current is 3 amps, resistance is 4 ohms. So 3 times 4 is 12. So that uses up 12 volts of the 18 volts. Okay. And then D is combine the voltages of the 2 branches, branch 1 and branch 2, to calculate the voltage across the branch. So the voltage across each of these is branch voltage is equal to 18 volts minus 12 volts, and 18 minus 12 is 6 volts. So each of these branches have 6 volts. Okay? And calculate the current through branches 2 and 3. So if I just put the voltage across this is 6 and the voltage across that is 6, you know that current is voltage over resistance. So the current through branch, so I call that branch 1, branch 2, branch 3, 3 of them. So middle branch is 6 volts divided by 3 ohms. You get 2 amps. And there's a total, there's a total of 3 amps coming out of the battery. So 3 minus 2 is 1 amp. So you have 2 amps over here, and you got 1 amp current going through the bottom branch, and through that branch you've got 3 amps. Okay? Then use the current through the 3 ohm resistor to calculate the voltage across this. We kind of did this. This is like repeating the question. 2 times 3 is 6 and 1 times 6 is 6. So the voltage across them is the same. And then the last one, comment on the voltage across the 3 branches. The voltage across each branch is the same. Even though that shows 18 volts, we've got to take away the 12 volts from here because it's supplying 18 volts but using up 12 volts before it goes to the different branches. So the effective voltage of each branch is the same. Okay, so I hope that made sense. Bye for now, and your task for today is do questions 1, 2, and 3, and I hope to see you on Zoom at 12 noon. Bye for now.